Okay, so let's go ahead and have a look at what you need to
So,
understand.
can I ask,
Yep.
can we have lessons every day if you don't mind?
When are you writing again?
Next week, Monday. I mean, not Monday. Next week, Friday.
Yeah, we will. The times will change now and then. I think we can try and work over the weekend also. Yeah, I'll make a plan because I'm also doing grade 12. So that is the
Okay.
issue. But let's see. We'll try and make a plan. So I think let's push this one. So what we need to look at is your quadratic function. And what you need to remember, which is very important, is the two forms that we get this function on. So I'll say two forms. So whenever you're looking at a quadratic function, it is either they are going to give it to you as y equals, yeah, it's going to be y equals, let's say f of x equals ax squared plus bx plus c, as you remember, or the second form is going to be y equals, let's call it g of x, equals a into x plus p all squared plus q. So it means when you see something looking like one of these, you should know we are dealing with a quadratic function. And then what you need to understand about this second form here, so we'll call this one form 1 or type 1. Let's call it two types. Yeah, type is much more easier to remember. So we have two types. We'll call this one type 1 and we'll call this one type 2. So with this in mind, we need to try and note down what is important when we are dealing with a quadratic function. Well, what is important when dealing with a quadratic function will be one, especially when we are plotting it. I'll just say here, plotting. When we are trying to draw it, what is very important is X-intercepts, and this is true for all graphs. What is also important is our Y-intercepts. But also what is very important is something which we call the turning point. And for the remainder of the session, I will call the turning point TP, turning point. So what is this idea of a turning point? Well, it is simply where our graph turns. So let me quickly draw for you a dummy looking graph. And we have a look at this idea of a turning point. So we'll have our Cartesian plane like that. And let's consider having a graph, round one, and let's have maybe something like this. Right. So if you look at our nice looking graph there is somewhere where if you look carefully, if we go down this graph, will go down, down, down. Then there's a point where instead of going down now, it's like we'll be sitting at the bottom, then we change, we go up like that. The point that is here, that point there is what we call the turning point. So if you were to put a ball to roll from point A to B, it would start turning when it gets to that point. And that point there is called turning point. And remember that your graph can also be upside down. So it doesn't mean it will always face like this, but let's leave the A and B. So let's consider another graph on the same axis. And let's say the graph looks something like this. That there, if you look at the top, what we have here is also the turning point. So essentially, if you look at your graph, if we walk up the graph, we'll eventually get to that point. Then we start going down. So that is the turning point. But then what we need to start asking ourselves is, how do we even find this turning point? Okay. So when you look at our two graphs here, both of them have an A, if you look carefully. And depending on how the A value is, if it's positive, we get a graph that looks a certain way. So our graph is concave up if our A is positive. So meaning you see the brown graph here, this one is an A value, which is positive. So that graph, we call it concave up. And then the purple graph, the A value for this graph is less than 0, meaning negative. So once we have a negative number wherever we see A, we know that what we will have is a graph that is concave down. So as you can see, the purple graph is facing down. Okay. So now that we've spoken about the turning point, we should ask ourselves, if given a function, how do we find the turning point? And this is very important. How do we find the turning point? Sorry, the turning point. How we find the turning point will depend on which equation we are using. Remember, we said there's type 1 and there's type 2 above there. So let's consider when we are using type 1. If we are using type 1, where our equation will be ax squared plus bx plus c, how we find the x value of the turning point, xtp or pt, we'll be using the formula negative b over 2a. This is very important for you to find, because we said for a quadratic, what is important is the x-intercept, the y, and the turning point. So here, what I'm giving you is a formula for calculating the x value of the turning point. Of the turning point if we are using type 1 equation. And then obviously the turning point, remember, it is a coordinate. So we'll ask ourselves, since we now have xpt, which pt, remember, said it's the turning point, what is ypt? Meaning, what is the y value of the turning point? For us to find the y value of the turning point, we will sub xpt, meaning the x value of the turning point, into the equation to find y, to find our ypt. So that is what is going to happen. And this, very importantly, is if we have form 1 or type 1. So now we need to ask ourselves, what happens when we have type 2? So what about type 2? Sorry, what about type 2? So remember, type 2 looks something like this. So with type 2, you have y equals a open bracket x plus p whole squared plus q. So with your type 2, we can read our turning point from what is given. With type 2, what you should notice, there's no need to calculate the turning point. There is no need. What we are going to do is we are going to read off the turning point from the equation. that is what we are going to do. We are going to look at the equation and read it off. So look at how the equation looks. I'll zoom in and show you how we get our turning point. So we have y into x plus p whole squared plus q. So our turning point, TP, will be the x value. We take whatever which is here. So usually our equation, you will see it usually as a plus, but we'll always take negative p. So meaning whatever which we see there, will always take negative of it. So we'll take negative p. And then our y value will be q with the sign that it has. So it will always be just q. That is how we are going to read our turning point when we have type 2. Do you understand? Awesome. I see a thumbs up. So that is very important to understand our turning point. So what is also important is obviously if we have the two types, your X-intercept and your Y-intercept, which you already know how to find from previous functions, straight line type of functions. So what I'm going to do is I'm going to pop a problem on the screen, and then we'll start doing some work. So let me see how. So what I need you to do is, let's work through the question first. Yeah. So we're looking at question 6. So we are told that the graphs f of x, which is negative x squared plus 7x plus 8, and g of x, which is negative 3x plus 24 are sketched below, where f and g intersect, meaning they equal at the point B and D. And then the question says, determine the coordinates of A and B. So I need you to help me to identify what is A and B. When you look at them, look at where A is, look at where B is. So remember,
So A is your um X intercept.
Yep. So A and B, actually, both of them are the X-intercept. Do you see that? So the horizontal line is the X-axis. And remember, on the X-axis, what we always have as true is that our Y is equal to 0. Do you remember that?
Mm-hmm.
And the vertical line, we call it the Y-axis. And what do we know that is always true on the Y-axis?
Our X equals to 0.
Yep, genius. Your X is always equal to 0. So when we now go to 6.1 and look carefully at A and B, what we do realize is that these are the X-intercepts. So they are the X-intercepts. But what is very important is to realize X-intercepts of which graphs. So we can say even graph F. So they are the X-intercepts of f of x, the graph f, which is the parabola. Okay. So we know that whenever we are looking for the X-intercepts, life is easy. So when we are looking for the X-intercepts, all what we need to do is wherever we see 0, wherever we see y, go and put 0, and then solve for x. That is what we always do. Do you agree?
Mm-hmm.
Awesome. So when we look at our equation, we were given y equals x squared minus 7x, x squared plus 7x plus 8. So it means wherever I see y, I need to replace it with 0, so that I have 0 equals x squared plus 8x plus 7. So I need you to help me to factorize this. We need two numbers. When you multiply them, you get 7. And when you add them, you get 8. So we get 8 when we add them. We get 7 when we times them.
So,
Mhm.
I think you flip things around. It's 7x, not 8x.
Oh, let me see. Okay. Yeah, you are correct. So there's a negative even at the front. Negative 7 squared plus, that is 7x plus 8. Okay, let's fix that. So negative x squared plus 7x minus or plus 8. So we don't like the minus there. So what we'll do is, before we even start trying to factorize, we'll usually transpose everything. So that we'll have x squared and then minus 7x and then minus 8 equals. So can you factorize this? We're looking for two numbers. When you multiply them, you get minus 8. When you add them, you get minus 7.
Negative 8 times 1.
It is what?
Negative 8 times 1.
Yep, it is negative 8 and positive 1. So you put in x, and this must be equal to 0. So this means x minus 8 must be equal to 0, and x minus or x plus 1 must be 0. So when we transpose, we get x is 8 and x is minus 1. So now we know that we have found our answer. We are on the x-axis. Obviously, y is 0. So now my question to you is, looking at our solution, what are the coordinates for A and what are the coordinates for B?
Coordinates for A is 8. Is 0.
You are a bit far from your mic. You sound very soft.
Coordinates for A, it's negative 1, comma, and then your y-intercept is 0.
Yep, negative 1 and 0 for B, it will be
8 and 0.
8 and 0. So we are geniuses. Look at 4 marks in the back. So let's go for 6.2. So for 6.2, they say calculate the coordinate A, the coordinate of D. So essentially, let's just go and determine the coordinate of D. So determine the coordinate D. So we coordinate D. So if you look at D, do you see that at D, this is where the two graphs meet. So f of x and g of x are equal. Do you see that?
Yes.
Yep. So we should note that at D, g of x and f of x are equal. Why is that the case? They are crossing at D. So when things are crossing, it means they're in the same spot. Same x value, same y value. So we're going to take the two graphs, equate them, and solve for x and see what we get. So my g of x is negative 3x plus 24 equals f of x, which is minus x squared plus 7x plus 8. And what we are going to do is to transpose everything to the side. Okay. So that what we will have is x squared minus 3x plus 24 minus 7x minus 8 equals 0. So we'll have x squared minus 10x when I combine minus 3x and minus 7. And then 24 minus 8. That sounds like a 16, isn't it? Mm-hmm.
Yeah, it's 17.
24 minus 8, it can be 17.
Oh, sorry. I get you with the 7. I don't think so. Yeah,
Yeah, you can't minus 24 in the 7. Why is that?
no, I didn't see like. Well, I didn't see the eggs.
Yeah, okay. So now let's go and solve for this. I need you to give me two numbers. When we multiply them, we get positive 16. When we add them, we get negative 10. Very easy. But like when I times them, I get 16. When I add them, I get minus 10. What are those numbers? It is what?
Yeah.
Let's get closer to your mic.
That would be 8 times 2. Yeah, it is 16. So it's negative 2 times. Negative 2 times negative 8.
That is correct. It is negative 2 and negative 8. So what we always do, you take this, you equate it to 0, and you also take the other bracket, you equate it to, minus 8, equate it to 0. So when we solve, we get x is 2 and x is 8. So what our equation is telling us is that these two graphs, they are meeting at two places. And that is correct. When we look at them carefully, they're meeting at D and at B. So the 8 there, we know that it must be this coordinate here, because at B, we got 8 and 0. So it means that at point D, the A they are looking for, remember D is A, comma B, meaning the x of D. So the A they are looking for is 2, because that is what the x is at D. So calculate A, the coordinate of D. Do you understand?
Yes, sir.
Right. Awesome. And let's now go to the next question. So what they're saying to us here is that we have a point S which is on the graph of F. There's the S there. And then they say where S is bigger than A but less than 8. And then they say ST is drawn in parallel to the y-axis. And then they say determine ST in terms of X. So we want to find what is the length of ST in terms of X. Okay, so this is going to be a bit easy actually, because once they say ST there, it means we are looking for the distance. So let's go to 6.3. So at S, we know that what we have is just X comma Y. Okay, that is the X value that we have. And then at point T, what we have is X comma Y2. Okay, But there's something I need you to think of carefully here. If you look at point S, we know what y is. So x we don't know, but we know y is given by the equation of the parabola. So y is the same as negative x squared plus 7x plus 8. Do you understand that?
So why do you say y is the equation?
It is because y is represented by that equation, and they want us to determine our length of st in terms of x, meaning if we want to use the distance formula, we can't have any y's. But already we know that throughout this curve, actually y is always given by your equation of the curve.
Always.
Always, all the time. So all what we did is we took what y is according to what we are given and we put y in place of y. That is what we did. X is x, but y is always an equation. You understand? Now look at t. So at t, x is x. But when I look at where t is, t falls on a graph. And the graph it falls onto, you see it's the straight line graph.
Mm.
So for the straight line, what is y equal to?
Negative 3x plus 24.
On point. So it is negative 3x plus 24. And remember that now when they are saying find as t, what they are telling us is that they are looking for the distance. That is what they are looking for. And I want to remind you of something that you shouldn't forget, which is your distance formula. So with our distance formula, let's say we are looking for the distance of AB. It will always be the square root of, we'll take the x of B minus the x of A, square the answer, then plus the y of B minus the y of A, and square the answer. That is how we find our distance. Okay? So it means here, or you could swap these and make x of A minus x of B. So if I'm looking for ST here, it means I'm going to say the square root of, I'm going to do the x of t minusing the x of s, square the answer, plus the y of t minus the y of s, square the answer. Do you understand?
Yes.
Right. So this means what we are going to have is the square root of, it's going to do the work. So we have the x's. So look at the x of t, it is x minus x all squared, plus, let's go into the y's. So for the y's, what I have is, let me put this bracket. What I have is negative 3x plus 24 minus negative x squared plus 7x. Let's create some space. So this will be plus 7x plus 8 all squared, like that. Do you understand?
Okay.
So when you try and simplify, you will see that what you will have is, let's open the bracket. So I need to put in second one. Square should be here. So if you look carefully, what we are then going to have is something like this. So we'll have minus 3x plus 24 plus x squared minus 7x minus 8. And this is all squared. And remember, the square and the square root, they always cancel. Okay? So this means that our ST will simply be, if you look carefully, it will be x squared minus 7 minus 3, that will be minus 10x. then 24 minus that becomes plus 16. So that is what our ST is equal to. Do you understand?
Yes.
Okay, awesome. So that is what we have. So our ST in terms of X is that. Then 6.4, they talk about the maximum length. So they are saying, what is the maximum length? What do you think we should do there?
Yeah.
Mhm.
With 6.3, yes. It looks like it takes us back to 6.3. Why is it too much if I have to do all of this work?
So what you could have done actually was that if you have a vertical line, you could have easily just subtracted the y's. So you subtract the top graph from the bottom graph and you get your answer. You see, that you could have done. Because remember, the graph here at the top is F and the one here is G. So your ST you could also find by just saying F minus G. And that would also still work out.
Right.
Yep. Do you understand?
Yeah.
So this general formula, the approach that I take, it works even when the lines are not, even when the line is not like vertically straight. When it's vertically straight, you could have just worried about the y's only, and you were going to get the answer. So we can even do that to say, when you have a case like this, yeah, let's do that. Just keep the one we had in mind like that. Maybe let me just make something that might be useful for you. So if ever you are looking at a straight line like this, like that, and you have, let's say, a coordinate here, which is A, and you have X of A and Y of A as an example, and then you have B here, then you have X of B and Y of B. If they look for what is the length of AB, like that, you could find AB by simply taking the Y at the top, which is Y of A, then minus Y of B. This applies when this is a vertically straight line. So this means that for our problem, when you look at the Y values, we could have even said that ST for those two marks is going to be F of X minus G of X. And then our ST was going to be negative X squared plus 7X plus 8 minus negative 3X plus 24. And the answer which we get for ST will be negative X squared and plus 10X and then minus 16. So the answer is different from the other one by a negative, but that does not really make much of a difference.
Can't we divide by -1 to get positive X squared?
Yeah, we can, but there's no need for us to do so.
Okay.
Yeah. So let's leave it as it is. There's no need for us to do so. And then now they say here we should calculate the maximum length. So remember, we are calculating the maximum length of ST. So now what they are talking about here is essentially about the function which is above here. So remember, the function describes the length ST. That is what it does. It describes our length. And remember, with the turning point, which I need to mention, what we have here, when our function, you look at the purple function, you should be able to see that with the purple function, when it is concave down, do you see that we'll have a maximum value at the turning point? This will be the biggest value, because as we go towards the right, we are climbing our mountain. Then when we get there, it's the highest point. So meaning when we have a concave down, we have a maximum. Do you understand? Maximum value. Does it make sense?
Yes.
Then when we have a concave up, which is a smiling face, when we walk from left to right, we don't have a maximum point. We, in fact, have a minimum point. We'll reach a point where we are at the lowest before we go up. So that turning point there is the minimum when we have a concave up. Do you understand?
Yes.
So now with that understanding, when we go to our problem, you will see that our A is negative. So when A is negative, that means we have A. So A is -1, which is less than 0. So this means we have a concave down. Do you agree?
Mm.
So we are not smiling. And when we have a concave down, as you can see even here, it means if we walk, we'll eventually reach the maximum point. So meaning we have a maximum for this thing. And the maximum, remember, it is at the turning point. So when they say find the maximum length, it means I need to get the x value of the turning point, then plug it back there, then I'm going to get the maximum length. Do you understand?
Mm.
Does it make sense?
Yes.
Right. So I need you to quickly calculate the turning point for me. Remember, we have a formula. Do you remember the formula?
Yes.
We have a formula for turning point. But specifically, it helps us to find x, not y. What is that formula? XTP
minus b over 2a.
minus b over 2a. So looking at our ST there, what is a?
-1.
So a is -1. What is b?
Okay. 7. Positive 7.
Nope, look at ST. We are looking for the maximum length for ST. So we look at the function that describes ST.
Oh, so we're looking for this equation, not the extra equation. Oh, okay. So our b is 10x.
B is 10. So we're looking for the equation, the turning point of the equation that describes the length of ST, because they are saying what is the maximum length of ST. If they were saying what is the turning point of G of F, then we would have done that. So now I need you to go to your calculator, punch in this, and tell me what you get as our x of t.
So this is 5.
You are saying you are getting
5.
5. So xtp is 5. So now that we have 5, we need to now go and find the distance. And remember how I said after finding x, how do we find y? We go and plug back. So our st will be negative. So it will be -5 squared plus 10 into 5 minus 16. What is our maximum length?
Nine.
It is 9.
Mm.
9 units. So that is our maximum length. It means the maximum length we can have if we try and move this thing around here, it is going to be a maximum of 9 units. So that is that. So now what I need you to do, copy this. Now that you have learned about turning points, I'll copy this graph here. I need you to go and find me the turning point of this graph of ours here, f of x. So I need you to determine the turning point of f of x. So find it, and then you'll tell me what is it and how did you go about it.
7/3.
It is what?
7/3.
What is 7/6?
That's your x.
Yep, we need to be specific. So your XTP, turning point, you got 7/6.
2.
2.
2.
And then what is your Y of your turning point?
Um,
Are you still calculating Y?